Whoop. Let me just check that I've got everything here. Right. Here we go. Who here is worried about security? Right. Who's had a pen test or a code audit done on what they've written? See, there's a bit of a gap there. Maybe you should be worried about it more. One of the problems with getting stuff pen tested and audited is that pen testers are expensive. So you can get better value out of them by avoiding them having to report on all the easy stuff that you can fix yourself. So who am I? Wait, I'm missing focus. Where's my mouse gone? There we go. Right. Who am I? This is me. I took this picture last year. That's a selfie, believe it or not. I am a skier. I live in the French Alps, though I was originally British. I'm now French. My Brexit escape plan has succeeded. Now, even though this is a JavaScript conference, I bet that a lot of you have run code that I wrote, because I'm also the maintainer of PHP Mailer. Which is an insanely popular package, and like everybody uses it, and it's in WordPress and so on. I also write songs about open source, which you can find on my SoundCloud. But most of the time, I work for this company called Radically Open Security in Amsterdam, and we do pen tests and code audits. So we break into your websites and look at your code and tell you what you're doing wrong and how you're going to fail horribly. And we do pen tests and code audits for all kinds of different people, all the way from single-person open source projects, all the way through like supermarket chains and national infrastructure. We've done tests on things that you'll be using. For example, Homebrew, iTerm, Tor. We did an analysis of the protocol for the Apple-Google COVID tracking protocol. And the thing that I've learned about this, my role there is not really actually pen testing on the whole, though I do some code audits in PHP. But what I do is I review and edit the pen test reports. And the thing that this shows me is that everybody makes the same mistakes. Regardless if you're just a one-person open source project or a supermarket chain, you're going to make the same mistakes. So this stuff is useful and general. So let's have a look at the typical deployment stack that I'm sure probably applies to most of you. Now, on the outside here, we've got our cloud provider. It doesn't really matter who it is, whether it's AWS, Azure, or whoever. Inside the cloud provider, we have some infrastructure, which is usually the network, a bunch of VMs, some storage services, and lots of other things that cloud providers provide. On those resources, we then run our own services. That's our databases, our web servers, caches, language servers, whatever. And then somewhere on the outside, we have our clients. And these are typically browsers and things like mobile apps. But also, this is where we think of, for the most part, of our attackers living. Now, there are other classes of attacker that are not on the outside, like rogue administrators. But that's a more difficult problem we're not going to deal with today. You'll notice this red arrow here. Now, this is really the kind of the critical path of information flow between the clients and what's going on the inside of our system. And you'll notice that this red arrow crosses various boundaries. And each of these boundaries that it crosses is an opportunity to apply security controls, layers of defense. But to be useful, these boundaries have to be somewhat porous. We need to let some things through, but not other things. And one of the key things that this gives us is the ability to do what we call defense in depth, which is to make it that if somebody manages to get through one of these layers, then they're caught by the next one. But for a moment, let's put a different hat on and think about this from the attacker's perspective. And this is an exercise known as threat modeling, and there's a whole discipline related to this. But this is approximately what we're going to do here. What are attackers looking for? The number one thing is just information. They want to find out as much as they can about the stuff that you're running. Now, information itself is not a direct threat, but it's the starting point for everything else. And then one of the number one things they're going to be looking for is outdated software. If your web server is out of date, or your language processor is out of date, and they can see that, they might be able to go, oh, well, that particular version has a known vulnerability, and it's got an exploit in Metasploit. I can just type in the host name and point it at that thing and press go, and look, I'm in. This makes it very easy for them. The other thing they're looking for is misconfiguration. Your stuff might all be completely up to date, but it might be badly configured. You might, for example, have some great options for encryption on your TLS connection, but you might have some really bad ones too. Errors are a great source of information, particularly if you've done something a little silly, like leave stack traces enabled, and it just provides a nice long list of everything that's gone wrong inside your application, and this reveals things like internal host names, paths to where files are stored, exact versions of packages that you're running. Lots and lots of information can be given away through error messages. Inconsistencies in validation and escaping. A classic problem here is where you do some validation on the front end, but then fail to do the same validation on the back end. And an attacker can interfere with what happens in between the two and get past all the security that you put on your front end. So let's have a look at these different layers. And the first of these really is the cloud provider itself. And they provide some good facilities that give us a solid grounding in our security. And the first of these really is IP addresses. You might not actually need an IP address, or certainly not a public IP address for your VMs at all. For example, a database server that's on the inside of your cloud network probably doesn't really need to be accessible from the outside world, though you might want it for administrative purposes, but there are ways around that. So having instances that are not accessible from the outside world closes a lot of attack surface. They'll also provide security groups, and these are kind of like a slightly blunt, simple firewall, and it just allows you to enable access to bits of your internal network inside your cloud provider to open ports on TCP and UDP and whatever else it is you want. You can control access at that level. They can also provide SSH bastions. These are sometimes known as jump hosts. And the idea here is that to save you being SSHing directly into back-end servers, you log into this bastion host and then on in the inside of your network to the ones that are kind of hidden behind the scenes. And if the cloud provider provides this service to you, those instances will be very strictly controlled, heavily locked down, and they only do that thing and nothing else. So they tend to be quite secure. Better than setting up your own, certainly. The other thing you'll usually get from cloud providers is the VM images and container images that you're running for your system. And it's really common for these to be outdated. If you go onto AWS right now, spin up an EC2 instance with Ubuntu on it, log into it, do an apt update, you'll probably find there are outstanding packages that need updating. So you need to be aware of this going on all the time. Once you're actually inside your instances, we can then have firewalls actually on our instances as well. And these give us a little bit more control than the ones that are up at the cloud provider level. And the first rule really here is that you want to block all traffic by default and then only allow what's needed. You've got a bit more control down at this level there, and you can also do things like setting rate limits, which is really good for helping block brute force attacks. Another thing that you might want to consider is outbound limits. And these are where you have connections that are initiated from the server and then go out to other things. Now, this can be bad. You can have something called server-side request forgery, where you can trick a server into making requests that do something bad. So you might want to limit what those servers can do. And you can do that by, for example, providing an allow list of domains that the servers are allowed to contact. But usually the only things that servers really need, almost universally, is the ability to do DNS lookups and also to fetch packages for their own operating system updates. And you can work around both of those by running your own internal DNS server and also by running your own internal package mirror. One thing though, don't forget IP version 6. It's really common for people to lock down all their IP version 4 stuff, leaving IP version 6 wide open when everything's listening on the same ports internally. Having done all that, how do you check that you've actually done it right? Well, this is the pentester's best friend, Nmap. Nmap is a simple tool that's got a stupendous array of command line options, does all kinds of things. And the number one rule of Nmap is do not point at other people's servers without asking them, because it's a good way of triggering security things. And in some places it's illegal and will get you into trouble. However, you can point it at your own stuff without any problem at all. So this command here with the -p- says, basically just check whether whether all ports are open. And this is all 65,000 ports, so this takes a little while. I'll show you a demo of this working in a bit. If you are going to have, you may not need SSH access at all, partly because you could be doing this via a jump host. But if you do, make sure that you use keys, like public-private key pairs, and not passwords. Passwords can be brute-forced or use password spraying attacks. They go and download huge databases of passwords and attempt to log in using them. Just don't do that. When you make your keys these days, you should really be using these elliptic curve keys called ED25519, rather than the older, much bigger RSA keys. Elliptic curve keys are smaller, faster, and stronger, and supported in all modern SSH implementations, and you really should be switching to those. You can tell quite easily. If you look at an RSA key, particularly if it's like a 4096-bit key, it's like a couple of screenfuls of text. It's a great big thing. Whereas an elliptic curve text that's actually, key that's actually stronger is only a couple of lines. You can run your SSH service on non-standard ports. By default, SSH runs on port 22, but you can run it on things like port 2222. That's quite common. However, it doesn't actually make you any more secure. It just really turns the noise down in your logs a bit. The default configuration of a lot of SSH servers is actually not that strong out of the box, and you can improve this quite a lot. And there's this really nice utility called SSH Audit, which I'll show you in a bit, which tells you what's wrong with your configuration and also gives you advice on what to change. You can also connect SSH access to your firewall through this package called fail to ban. What fail to ban does is you can get it to monitor any log file, in particular looking for login failures, and then if it has more than a certain number of login failures within a certain amount of time, you can actually get it to just raise firewall blocks. And the advantage of that is that not only does it block the SSH attacks, but it blocks all other attacks coming from that same IP. Going on to the operating system updates, it's really important to make sure that these get deployed. Unfortunately, there are nice ways to automate this. On Debian Ubuntu, there's a package called unattended upgrades. On Red Hat and Fedora, there's yum cron. And on Windows, there's update and defender. Now, some people get a little bit worried about allowing the operating system to update itself kind of unmonitored. I've been doing this kind of thing for over 20 years, and I've only had this go wrong once. And the only effect of it going wrong was actually to disable unattended upgrades. My kind of sort of philosophical point of view is that an outage caused by an update going wrong is likely to be much less damaging than not applying it and then exposing yourself to a known vulnerability. One of the nice things about this is that it's something you can just fix in one place. You just set it once, and then all your security patches will get installed automatically. So now we've got our VMs all set up. We're going to run some services on them. Probably the first of these is going to be a web server. It doesn't matter if it's Apache, Nginx, or Caddy, or whatever you want to use. But the main things we want to configure from a security perspective is going to be TLS and the HTTP headers that you can attach to things. Strangely enough, this has been done before. And if you go to this site that's hosted by Mozilla, you can put in your operating system, the web server that you're running, and your target audience. This is really just trying to get a feel for how much legacy support you want to have. And it will generate you a pretty good configuration that you can just copy and paste into your server. Your database, cache, and queue servers, anything else, should not be accessible from the outside. And an additional layer from that, as well as, for example, the cloud provider blocks and your firewall blocks, is also avoiding listening on all interfaces. Now, this used to be really common, but nowadays it's actually much less common. And now, on the whole, services will, out of the box, will only listen on localhost. So it means that when you're running your web server and it wants to talk to your Redis server, it just talks to localhost. So it's only just looping back to itself, and it's not actually exposed to anywhere else on the network. However, if you've got more than one server, you want it to listen on your internal network IP, but still not a public IP. And web server configuration is usually an easy place to set headers, but we'll revisit that in a minute. So these security headers, what are they? Well, I think the most important of these is this one, strict transport security. And this big number here is 1 year in seconds. And what this says is for that amount of time, from the first time you see this, you should only talk to this domain over HTTPS. This means, though, that the very first time you visit a website, your browser is going to hit port 80, which is not encrypted at all. and then it'll get a redirect to the secure site where it then sees this header, and from that point onwards, all of the requests are going to be encrypted. However, that one single request at the beginning is itself a security vulnerability, and it's a great opportunity for attackers to try to get in there. I mean, it's difficult, but it's an opportunity nonetheless. And if you're serious about the particular domain that you're doing, and it's not just for demo purposes or just a temporary thing, you can add this preload keyword. And what you can then do is submit your domain to the preload list, and that list of domains gets downloaded into all modern browsers automatically behind the scenes. And it then means that if somebody is visiting your site for the very first time, your browser checks to see if the domain's in that list already. And if it is, the very first request will also be encrypted, skipping this trust on first use or tofu problem. Content security policy, this is something that's, I'm sure, dear to the hearts of many JavaScript developers that just really want to have that unsafe inline tag. Content security policy is really cool. It allows you to put very strict limits on where your page that you've loaded is allowed to load resources from. And the most common thing is just to allow things from yourself, from your own domain. But you might want to load stuff from elsewhere, for example, from a CDN. But content security policy is really quite tricky to configure. It's really a conference talk in its own right, and there have been many conference talks on this, just this header. However, one thing I'd say about these two headers is strict transport security. If you're running multiple websites on a single server, which is not uncommon, you would probably want to set strict transport security in your web server config. However, the content security policy is probably unique to each individual app, because each of them are probably going to have different dependencies coming from different places, allowing different origins. And so I would recommend that you put your CSP config inside your application rather than your web server config. That means that if you then take your app and install it on another server, you're going to get the right content security policy traveling with it. This is a kind of just a really small one. And this just tells browsers not to guess MIME types. It used to be really common for content to be delivered to browsers with incorrect MIME types. Probably the most frequent one was to have stuff being delivered as text/plain when it was actually HTML. And so what the browsers got into the habit of doing is looking at the content and going, hey, this thing that's meant to be plain text has got HTML tags in it, so I'm going to render it as HTML. And unfortunately, this was the source of many security vulnerabilities, and that was a problem. So if you set this header, it tells the browser explicitly, do not guess, believe what I say. If I say this is plain text, it's plain text, even if it has HTML tags in it. The referrer policy, if you have done something foolish, like put your session key in your URL, don't laugh, it happens. And you've got a link on that page that goes to some third-party site. The entire URL, by default, well, certainly used to be by default, I'm not sure what browser policies are by default these days, but the entire URL is passed through as the referrer header on the new site, which means that you've just given away as your session token to some third-party site. That's not a good thing. This policy header tells the browser what information that is allowed to pass on in the referrer header. And there are safe options, for example, just having the domain, or in fact having no referrer, which is completely safe, but also kind of breaks linking and isn't so good for SEO and things. Having set all this stuff up, you really want to be able to test it. Fortunately, there are some really good tools to do this. This is probably the most popular one. This is run by a company called Qualys, SSL Labs. And you can go on here and put in your host name, and it will run a whole load of TLS-based tests on your site, telling you what's good or bad about it, and it gives you an overall rating, which we'll see in a bit. One of the problems with that site is that it's only public. You can only test things that are actually accessible to the outside world. And if you're testing something that's on an internal network or that requires you to be on a VPN or something, obviously you can't test it from the outside. So there's this tool, which testssl.sh. This is also its domain name, so it's really easy to find. And you can just run this on a command line, and it does almost the identical test to the Qualys SSL Labs thing, except on a command line and locally, so you can just use it anywhere. It's also a bit faster. The Qualys things are really slow. Securityheaders.com, well, while the Qualys site does some checks on headers, this site makes it much clearer. And I really recommend it. It's also very fast because it's only testing something simple. HTTP3 check, well, you can probably guess what that does. It just tests whether your HTTP3 configuration is working. HTTP3 is a little bit tricky because it's port 443, but UDP, not TCP. And a lot of people's configurations won't support that out of the box. It takes a little bit of tweaking to get it working. This site is a Swedish university, I believe, put this together. And this tests things at a slightly higher level. And this looks at things from a kind of a privacy perspective, really good for your GDPR compliance. Where it looks at the existence of cookies and their settings, and also stuff that's loaded from third parties, in particular anything that could be construed as tracking, for example, Google Analytics. So let's have a little demo and have a look at some of these things. Now, I mentioned Nmap back at the beginning. So I've got this domain. In fact, actually, I'll just show you quickly. This little website here, this is just, that's all it is. It's actually served through PHP for a particular reason. I'm going to do nmap minus p minus 7,000 of bp.hacker.fun. And this is going to go and do a nmap test, and you see it's found a bunch of things that are open. Now, some of these we were expecting. Port 22, TCP, yeah, that's SSH. We're expecting that. Port 80 and 443 for HTTP and HTTPS, great. But look, we've got a publicly accessible Redis server. That's not good. Now, to be fair, I had to go through quite a few hoops to make that happen. Redis's default configuration doesn't listen on all interfaces, only localhost. And also, I had to make a point of exposing it through my cloud provider thing, which I'll show you as well. I mentioned SSH audit, so I can do SSH audit of bp.hacker.fun. Oop, I missed a... Okay. Now, this is a slightly messier output. If I scroll back a bit here, if I scroll right to the beginning, yeah. Now, just here, we can see that it shows the version number of the SSH server. That's actually okay, because SSH is actually, clients in particular, are quite heavily dependent on the exact version of SSH that you're running. So that's okay to have. But this bit here tells people that, hey, we're running Ubuntu, and we're running this specific version of the SSH server. So that means that if there's a known vulnerability in that version, attackers can just look at this and see immediately, hey, they're running a vulnerable version, I can get in by this mechanism. If I scroll down a bit, you'll see that we've got various stuff that's come up in red, is complaining that we're using an elliptic curve that's suspected as being backdoored by the NSA. You've got to be quite paranoid about these things, but then that's why people write tools like this. Lower down, we can see we've got this Diffie-Hellman group that it says is not strong enough. We keep scrolling down. We've got some hash functions or MAC functions that are too small or use obsolete encryption or obsolete hash functions like SHA-1. And then down at the end here, it gives us this nice little list here. It just tells us which things to remove from our configuration. Now, if you've actually got ones that it suggests that you add, they will appear in here as well. But all this can seem really very complicated. Fortunately, this little link here, if you go here, this will tell you all about what these things mean. And it's actually quite easy to set up a new configuration and deploy it, and it just closes all this stuff down. So this is actually how Ubuntu 24.04 looks out of the box. So you can see there's stuff to lock down right from this early stage. Now, going over here, if I look at this page here, and you can see I've got the request from the page itself. It's a little bit small in here, but down here we can see, oh wait, I'm looking at request headers. I'm looking at response headers is what I'm after. Yeah, here we've got Nginx 1.27.0. So we're actually revealing the Nginx version in our headers. And you can turn that off in the Nginx configuration. Further down here, you can see here that I'm also revealing the PHP version that I'm running. And again, just revealing that information is just exactly what attackers want to find. So that, again, you can just disable that in your php.ini. Having a quick look at the cloud provider. This is on AWS. And you see here we've got 3 security groups assigned. I've got the first one, which allows SSH access. I've got something that allows web access. And then just for the purposes of today's demo, I've got some other rules that just allow absolutely everything. And if we just scroll down a little bit here, we can see what these rules actually are. So you can see for SSH, we've got port 22 on TCP from all sources, and that's part of the SSH group. And then further down here are these port ranges of 60,000 to 61,000 are a protocol called MOSH, which is if you ever have trouble with SSH connections dropping, for example, you put your laptop to sleep or you go through a railway tunnel, MOSH solves that. Your connections will never die. It's really useful. Further down, we've got the web access, and then I've got these 2 rules that kind of, it's the one ring to rule them all, really, that just allow everything. But that's, say, don't do that in production. only allow the things that you actually want. Then I've got the results of the securityheaders.com thing there, and it's gone and checked all these headers and given me a full A+ rating on that. Similarly, this is the Qualys SSL Labs tests, and this is again giving me an A+ rating because I've been paying attention to my TLS configuration. And it shows you all kinds of other stuff down here, things like OCSP stapling, and that we've got TLS 1.2 and 1.3 only enabled. These 2 ciphers here, they probably need turning off. I probably deal with those. And then some simulations of what things are actually able to connect to this. So you'll see here that this red one here is that Chrome 49 running on Windows XP won't work. It's like, I don't care. The HTTP 3 check, there we go. We've got quick and HTTP 3 support because I've allowed port 443 over UDP in my cloud configuration. And then this is the privacy checker. Now, there's some overlap with some of the other things. So you can see we've got HTTPS by default because we've got the HSTS header set. We've got a content security policy, though it's complaining about some of the things in there. It's giving us a nice overview of some of the things that we're doing wrong. Now, this particular one is not doing anything too complicated, but yeah, there we are. So, whiz back to here, and we need to whiz through some last ones here. Inside your applications, things get a little bit trickier and more complicated because things are really spread out. You need to make sure you've got a strong password policy, and rather than having this like upper and lowercase and symbols and things, you want to make the passwords long, random, and not in known data breaches. And you can look up the passwords in haveibeenpwned.com in a way that doesn't actually reveal what the password is, which is kind of cool. You need to make sure that you're using a strong password hash function, which should be really bcrypt or argon2id. And make a point of putting rate limiting on the routes into your application that are particularly critical for security. And these are really sign up, login, and password reset routes. These are potentially dangerous areas of your app because once you've allowed somebody to log in, it just opens up a new world of attack surface. Implement 2-factor authentication, ideally using time-based one-time passwords, the little like 6-digit codes that change every 30 seconds, or more modern passkeys, but avoid SMS and email. Authorization is something that's inherently distributed throughout your app, but the number one thing really is the principle of least privilege. Only allow a particular user to do the things they need to do and nothing else. If you've got a very large, complicated process, it's very easy to give it these godlike powers to do everything, when a safer approach is to split it up into pieces and only allow each piece to do specific things. A really good example of this is the Qmail mail server, which runs a whole bunch of processes to do very small, closely defined things. That means that if any one of them gets compromised, it doesn't compromise the whole system. Your apps, of course, will have dependencies, whatever language you're running, and there are fortunately tools that will help you find these. NPM has NPM audit. In PHP, we have this really useful package, this one here. This contains no code, but it declares conflicts with packages that have known vulnerabilities. And this makes it very easy for you to nail these things down. Finally, cookie flags. Set the secure flag, particularly on your session cookies. These protect against interception. HTTP only, preventing scripts from accessing cookies, because that's the primary thing that attackers over cross-site scripting are going to be looking for. And the same site flag to defend against CSRF. Now, I'm running out of time here, so I'm going to squeeze through. On the front end, 3 rules. Sanitize. Doesn't matter if you remove stuff, it's not a transgression, but if you validate things, fail hard. If somebody types in something that's not conformant with exactly what you're expecting, stop at that point. And then escape everything on output. And this is really where the JavaScript people live. I don't think any other language actually has a complete class of vulnerabilities all to itself, which is cross-site scripting. That's quite a problem. And escaping itself is actually quite difficult because it depends on the context. We've got URLs, HTML, shell script, SQL, JSON, and even email. For example, it's possible to have 2 @ symbols in an email address. It's possible to have line breaks in an email address. It's possible for an email address to also be a valid shell exploit. These are things that are difficult to defend against. So you need to practice safe coding practices. Use tools to help you apply and enforce coding standards. Make use of static analysis tools, especially inside your IDEs. Make use of pre-commit hooks that allow you to detect people doing things like committing API keys, spotting debug statements in your code. And if you're doing stuff in public, GPG sign your commits, because it's really easy to fake names and emails and git commits. But overall, security is a process. It's not a thing. It's a moving target that requires this constant vigilance. You can really leverage things like your CI system to make it much more difficult to lose track and to lose focus on your security. But overall, that means that you can now let the pen testers do the hard stuff. Thank you.